Nikola Tesla died poor and alone, but one idea of his never died. The idea that the universe is overflowing with hidden energy we're simply not tapping into. Tesla believed that nature is saturated with power waiting to be harnessed, and that one day humanity would discover a way to draw energy directly from the fabric of reality.
We do our tests when the townspeople are sleeping. Mr. Tesla doesn't want to scare anyone.
Whether you see him as a genius or a dreamer, there's something strangely prophetic about the world catching up to ideas he planted over a century ago. Because today we're talking about a concept from quantum physics that sounds like something Tesla would have scribbled on a napkin: zero-point energy. The idea that even in perfect emptiness, the universe is roaring with energy. Not metaphorically, but literally. And if that's true, the implications for technology, society, and even consciousness are almost too big to grasp. Welcome back to Thinking and Being. If you like what you see today, please be sure to like and subscribe, as this will enable you to see more content from myself and others just like this. Just go ahead and click all the buttons and see what happens. I don't think you're going to regret it. So why does zero-point energy matter? Zero-point energy isn't one of those sci-fi tropes you play with just for fun. It's a real scientific phenomenon predicted by quantum mechanics, and yet it still feels magical. It sits at this uncanny intersection between physics, philosophy, and human imagination. On this channel, we tend to be in the space of where wonder meets logic, and zero-point energy is exactly in that space. It invites us to ask, what if the universe is far more energetic, far more dynamic, and far more accessible than we ever imagined? And what if one day we learn to use that energy? Even if the engineering isn't possible yet today, thinking about zero-point energy forces us to reconsider everything: what we call empty, what we call possible, and what future civilizations might eventually unlock. So today, let's just step out into that thought experiment, grounded in science, but stretching the imagination just enough to see beyond the edges. So let's think of the world as an ocean of energy. To understand the cultural pull of zero-point energy, you have to start with Nikola Tesla. Tesla believed that Earth itself was alive with vibrational energy, not metaphorically, but physically. His Wardenclyffe Tower was an attempt to transmit energy through the atmosphere wirelessly, using the Earth and ionosphere as conductors. Was it zero-point energy? No. But psychologically, Tesla believed in the neighborhood of the idea. He believed energy wasn't just something produced, it was something tapped, something already there, something universal. When he speculated about the very wheel work of nature, he was hinting at truth physicists would only articulate decades later: that the universe isn't a cold void, it's a restless sea. Tesla didn't have the math, but he absolutely had the intuition, and that intuition is the doorway into today's quantum mysteries. Let's address the vacuum that isn't empty, what zero-point energy really is.
Now, commence Operation Vacuum Suck! Suck, suck, suck!
Here's the scientific core. In quantum physics, even a perfect vacuum, a region with no particles, no matter, not even light, still contains energy, because the quantum fields that make up reality never fully shut off. They fluctuate, they jitter, they produce temporary virtual particles that pop in and out of existence, and this minimum level vibration is called the 0 point, the lowest possible energy a system can have. And it's not theoretical, we've measured its effects. The Casimir Effect pulls two metal plates together using nothing but vacuum fluctuations. It's bizarre, but it's real. So the idea that empty space is actually a seething ocean of potential energy isn't pseudoscience, it's physics. The problem is not that zero-point energy doesn't exist, the problem is that we have absolutely no idea how to extract it.
Here is an ordinary square. Whoa, slow down, egghead. But suppose we extend the square beyond the two dimensions of our universe, along the hypothetical z-axis there. This forms a three-dimensional object known as a cube or a frinkahedron in honor of its discoverer. Hey.
And here's the engineering wall and why we can't use it just yet. Zero-point energy, if it's everywhere, why aren't we running our cars, cities, and civilizations on it? Simple. Physics says you can't extract energy from the lowest energy state. It's like trying to siphon water from the bottom of the ocean without going lower than the ocean floor. You can't create a pressure difference because the vacuum is already at its minimum. So while zero-point energy is real, usable zero-point energy is not. Not with any known physics, but here's where things get interesting. We once thought flight was impossible. Electricity we thought was magic. Quantum mechanics we thought was nonsense. Even now, physicists speculate that future theories, quantum gravity, vacuum engineering, exotic space-time geometries might change our relationship to vacuum energy. Not today, maybe not this century, but the door isn't locked. It's just really, really heavy and hard to open.
Hey, all right, so the compression and expansion of the longitudinal waves cause the erratic oscillation, you can see it there, of the neighboring particles. Guess what is it? What is it?
Can I play with it?
No, you can't play with it. You won't enjoy it on as many levels as I do. The colors, children.
So if we could extract zero-point energy, what happens to our world? Let's imagine responsibly that one day we crack it. Energy becomes effectively infinite and free. Geopolitics collapse overnight. No oil, no gas, no grid monopolies. Transportation becomes trivial. Long-distance travel becomes as cheap as microwaving popcorn. Poverty becomes an engineering challenge, not an economic one. Climate change ends within a decade. Entire industries vanish. New ones explode into existence. Culture evolves at light speed. All of this isn't utopian fantasy. It's simply what happens when the cost of energy approaches zero. Energy is the master variable of civilization. And when you uncap it, everything else cascades. That's why zero-point energy sits at the edge of science and myth, because the implications are mythological. It's Prometheus level. And every Promethean idea has a shadow. So what is the shadow side? Why infinite energy might break us? Unlimited energy sounds like paradise, but it comes with existential questions. Who controls it? How do societies adapt when scarcity disappears? Do economic systems built on competition collapse without energy constraints? Do powerful nations suppress the technology? Do new inequalities appear? History shows that humanity struggles with abundance just as much as scarcity. So if zero-point energy were real and extractable, our biggest problems wouldn't be technological. They'd be psychological, ethical, and political. Infinite power forces a civilization to confront its maturity level. And that's where we introduce the missing puzzle piece. So what is that missing piece? Why physics still can't explain all of reality. For all of its success, modern physics still has a giant blind spot. It has no idea what to do with the idea of consciousness. Not in a mystical way, but in a very literal way. Quantum mechanics works, relativity works, but when you try to combine them, the math breaks. And the one phenomenon every human directly experiences, awareness, isn't accounted for anywhere in the equations. This doesn't mean mind over matter, it means something more subtle. Our models of the universe are incomplete. So instead of asking how do we extract zero-point energy, the more interesting question becomes what part of reality are we not modeling that makes zero-point energy unusable today? And that's where this gets exciting, because the thing that's missing may be the thing that we are experiencing every day. And here's a new angle, consciousness as a selector, not a generator. Here's the big shift. What if zero-point energy isn't something you extract, but something that becomes accessible only when you're in the right relationship with reality? Not mystical, more like information theory. For decades, physicists have debated whether consciousness collapses probability. What if that framing is too narrow? What if consciousness doesn't collapse anything, it selects? Like tuning a radio, like picking out one frequency from the noise. In that model, the vacuum always has energy, but not all energy states are equally accessible, and our interaction determines which vacuum configuration we're in. That small shift leads to a major implication. Access to zero-point energy isn't blocked by engineering, it's blocked by our perspective. And once you allow that, then the model can open up. And so here's a potential three-part model. The Resonant Vacuum Model, a new conceptual model for zero-point energy. It's simple but powerful. Number 1, the vacuum has structure, not random noise, pattern fluctuations with stable and unstable configurations. Physics already hints at this vacuum topology, symmetry breaking, and the Casimir Effect. Number 2, consciousness is a pattern-matching system. It doesn't create energy, it identifies and locks onto configurations that align with certain informational states. 3, technology is the bridge. An advanced civilization could use machines not to extract zero-point energy, but to stabilize vacuum configurations that already contain usable energy. So it's not like mining energy, it's more like pinning energy, like selecting the right layer of reality instead of trying to rip energy out of the lowest one. This is a brand new idea. Zero-point energy becomes usable only when consciousness and technology match the structure of the vacuum. If this model is right, let's just assume, then zero-point energy extraction isn't about brute force, it's about alignment. Just like how superconductivity appears only when matter is cooled into the right quantum state, zero-point energy might require that reality itself be placed into the right informational state. So what are the implications of that? Future zero-point energy devices won't pull energy, they'll tune to it. Consciousness may act as a stabilizing factor, selecting the state in which zero-point energy is accessible. AI, which excels at detecting hidden structure, could help map vacuum patterns. Humanity's path to zero-point energy might require a hybrid of physics and computation and consciousness, not just bigger particle colliders. And the engineering challenge becomes one of resonance, not extraction. So suddenly, Tesla's intuition, energy as vibration, doesn't sound so mystical. The universe might not release its deepest energy until the observer is capable of meeting it halfway. So that's the theory, synthesized from everything we know and everything we're beginning to imagine. And keep in mind that the universe is way bigger than any of our models. Tesla once said, if you want to understand the universe, think in terms of energy, frequency, and vibration. Maybe he wasn't describing physics. Maybe he was describing humility. That the universe is deeper than our textbooks. That reality still has secrets. Zero-point energy is one of those rare ideas that reminds us the frontier is still out there. We haven't reached the edge. We haven't even come close. And the future may be stranger, brighter, and more surprising than anything we've built so far. Not because we discover infinite energy, but because we discover infinite possibility. Thanks for watching today. My 3 key takeaways are: empty space isn't empty, it's quite alive. Next, Tesla saw the possibility long before the math existed. And last, the future belongs to civilizations that harness not just energy, but consciousness. So what do you think? Is there energy everywhere? Is there a missing piece of zero-point energy that I missed? Comment below and tell us. If you like what you saw today, please like and subscribe, as it will keep content like this coming your way. And stay tuned for more around physics and philosophy and psychology and all the intersections in between. But until then, keep thinking and being, and do not go gentle into that good night.